So hello guys, so this video is going to be your game changer. So whether you're preparing for JEE, NEET, GRE, SAT or any particular competitive exam, so anything in chemistry you will be able to solve in just minutes. So let's see the questions. So the first question is from JEE Advanced 2017 paper 2 offline as already mentioned. So in the first paper we have 4 structures, so in which we have to find out the basicity order. So we see in the in 1, 2, 3 and 4 structure that I'm marking right now, so the more number of nitrogen atoms you see are present in the fourth structure. So more number of nitrogen atoms, that means more nucleophilic sites. So nucleophile basically are electron rich, so more they are electron rich, that means the more the n atoms, the more it will be basic. So that's why basicity of fourth one will be more. Now next we talk about basicity is inversely proportional to resonance, but it is opposite in the case of acidity. So what happens here is that when this 2 and 3 are involved in resonance, and in 1 also resonance is there, but it is not in that extended conjugation as the other structures were. So therefore the order of basicity is 4, 1, 2 and 3 as you already see. So more the basic atoms, more the atoms which are having lone pair, more will be the basic character. Now this next question is also from JEE Advanced. So this reaction is basically, you see, multiple step reaction these are. So we take 3 moles of acetylene or ethyne molecule, so it goes into 2 plus 2 plus 2 cycloaddition, because the nature drives it into more stable form, that is benzene. So in the presence of iron tube, cyclization in the form of cycloaddition 2 plus 2 plus 2 reaction takes place. So the product here that we get is benzene ring. So the higher temperature drives the nature to the aromatic character. Now we get A as benzene. In the next part you see that in benzene each carbon has hydrogen, so means 6 carbon and 6 hydrogens we have. This reaction is also known as Friedel-Crafts reaction. So in this reaction that we see, we are using AlCl3, that also in anhydrous form. So anhydrous means that does not contain any water or crystalline nature of that substance. So AlCl3 is taken as anhydrous salt. So basically here, due to inductive effect, specifically due to minus I effect, it causes the acidity of AlCl3. So 3 electron withdrawing groups are attached, that are Cl. So what they do is they are electronegative in nature, so they try to attract electrons from Al. So it makes positive charge intensity on Al, which causes minus I effect on it. So more the minus I, or the more the positive intensity or positive magnitude on the central atom such as Al over here, more it will be acting as a good Lewis acid, which will be promoting electrophilic addition reaction. So in this one it promotes electrophilic addition reaction. Now the intermediate that it forms is due to the delta positive charge on Al, it attacks the Cl minus from the reactant molecule itself, and it gets attached to the AlCl3 molecule, causing it to form a intermediate such as AlCl4 whole minus. So it is a catalyst, it will not be used up in the reaction. So while we are doing the reaction, the rest of the alkyl group that we broke from here, that gets positive charge, gets attached to the benzene ring in the place of H plus. Now the H plus that has been taken out from the benzene ring gets attached to the Cl minus that initially we attached it to AlCl3 due to its positive charge. So this reaction is known as Friedel-Crafts reaction or electrophilic addition reaction. Now in question it's written that B is formed 50%. So that means we have got 2 products as a result of A's reaction with the AlCl3 and the alkyl group that we had. So now we get 2 of the products. So basically this is due to rearrangement. We have taken the most stable product. Now the most stable product of B, that is formed 50%, goes up to another reaction which is with O2 and H3O plus. So now O2 is in standard form O double bond O bonded to each other. Now when we apply heat to it, and oxygen is taken out as nascent oxygen, which is actually acting as an oxidizing agent. This nascent oxygen forms peroxide linkage with the cumene. So cumene, we have two kinds of carbons, A and B, which I've marked. So A is 2 degree and B is 1 degree because it is attached to one carbon only. So we have two of B's and one of A's. So one of the A, which is 2 degree, is more stable, so it gets attached, it is attacked by the oxygen and it forms peroxide linkage. Now due to weak reactivity or weak bond of OO linkage, that is peroxide linkage, it breaks up in the presence of heat. Also, when we get this kind of intermediate, that is peroxide linkage, which we have broken down due to weaker bond strength of this peroxide linkage, also in the presence of heat, this breaks up into the radicals. Now this radical and the H3O molecule or the H2O molecule, now it also breaks up into H dot and OH dot. Now due to high reactivity and due to opposite polarity, it gets attached and forms phenol with the benzene ring, and the other part of it get extracted up and it forms byproduct, that is acetone. Now we see the next part. So now we have got CS phenol. So when phenol reacts with this acid chloride in the presence of pyridine, so pyridine is basically a basic molecule which is also aromatic, but note down in this the lone pairs of nitrogen are not participating in resonance, rather they are contributing to its basic nature. So now it is a base, so it will abstract hydrogen from phenol atom. So in this phenol atom, this acts as a good acid, because we have already discussed it earlier that if it has aromaticity or if atoms are participating into aromatic or resonance, so they are behaving like more acidic molecule. So now due to this, the pKa value, the phenol is a good acid, so it breaks up as H plus, it gives up H plus when it breaks up. So now we see when we break up the acid chloride molecule, when we break up this molecule, now C double bond O bond I cannot break because that will require more of energy. If I break CCH3 bond, that will not produce enough polarity to do this reaction. So the last option that I have is to break the CCl bond, which will give me polarity. C will be having positive and Cl due to high electronegativity difference in them. So now, due to opposite polarity of the O minus and CH3CO bond, this C of the carbonyl, which has positive charge, attacks on the O minus, which is negative in polarity. So it gets attached to that. Now it forms aromatic ester in that form. So D product is 100% an aromatic ester as shown. Now in next question, we discuss about the Huckel's rule of aromaticity, which is very important. So first rule is it should be cyclic. So if the structures are cyclic, obviously they are gonna be aromatic. Second thing is that they should be conjugated and planar, which means each atom in the ring should be planar or sp2 hybridized. Conjugated, which means either it can be three possibility, either double alternate bonds are there, or double bonds are there, or lone pairs are there. Third option, double bonds are there or any charge, positive or negative charge is there. Also, before starting this question, I want to let you know that whenever you get positive charge on the ring, you consider that as, or you count that as 0 electrons. Whenever negative charge, we count it as 2 electrons. Now in the first subpart of this question we have, so Cl, if we extract again as discussed earlier, this Friedel-Crafts reaction, so this acts as a Lewis acid, so again it will abstract Cl minus from it. So now due to this in minus I effect, as we already discussed, this AlCl3 attracts AlCl4, Cl minus from it, and forms AlCl4 minus as intermediate. Now to the reactant molecule, when we remove Cl minus, on the ring we have this positive charge on it. So it is a case of extended conjugation. So now firstly it is cyclic, secondly it is conjugated because it has double bond and alternate positive charge. Third one is that it has 2 electrons that are participating in resonance. So that's why it will be aromatic. Now in the second structure we have sodium hydride. So if you break it up, it has Na plus and H minus. So now from the ring reactant molecule, this H as shown comes out of it. Now H plus comes out and the ring gets negative charge. So I've already told you, whenever you get negative charge, you count it as 2. So first one, it is cyclic. Second, it is conjugated because double bond alternate to each other and they are alternate to negative charge. Now number of electrons that are participating in delocalization are 6. So 2 from the double bonds and 2 from the negative charge. In the third structure, we have 2 carbonyl groups that are attached. Now when we have this ammonia gas or ammonia molecule, lone pair of it, which causes basicity to it, now it will attack to the carbon of the carbonyl carbon, because due to electronegativity difference of carbon and oxygen, it breaks up as positive and negative. So carbon gets positive charge. So this nitrogen, which has lone pairs, electronegative in nature, attacks on this carbon of the carbonyl carbon and forms this intermediate. Now it will go into resonance in different multiple steps as I'm showing down. So now the positive charge on the N delocalizes all over the ring and stabilizes it. So, and also we have O negative charge which is there, but it will not be contributing to aromaticity over here in this case. So now after we draw the canonical structures of it, so after drawing canonical structures or the resonating structures, we get this as the final product. Now after this, we check up the other possibilities of being aromatic. So it is cyclic, it is aromatic, it is conjugated. So now it fulfills all conditions, so that's why it is also participating in resonance and it is aromatic. Now in the fourth structure in this ring that we see, now if in the reagent, that is H plus and Cl minus, HCl, we break it up as H plus and Cl minus, and again of the carbonyl carbon, due to electronegativity difference, carbon breaks up into positive, oxygen breaks up into negative. So now on the positive carbon, this remains as positive, and on the negative, now on the O minus, the H plus of the HCl attacks and it forms OH group on it. So now we check the aromatic conditions. It is aromatic because it is conjugated, cyclic and planar. So thank you so much guys for watching my full video. Now to watch more videos like this, you need to subscribe this channel and follow my Instagram account, that is @chemdigo. You can also DM me on the same Instagram account that I'm mentioning below. You can also email me in the email address that I'm mentioning down again. You can buy my personalized one-on-one lectures and you can get your desired result. So thank you so much for watching. Like, share and subscribe, and also don't forget to follow me. So in comment section below, let me know which series should I do next to help you out guys. Bye bye.